Welcome to part 2 of 3D printing cost series. In previous video I explained what are 7 major parameters that contribute to the 3D printing cost. I've been asked what can be done about it. In this video I will explain which parameters can be influenced.
Welcome to my YouTube channel Green-Eyed Explorer, where I explore further and beyond about tweaks, hacks, electronics and house repairs.
In previous video I showed that the major influencing parameters are printer cost with its upgrade, electricity cost, consumables, PC with its software, filament cost and failure rate. I sliced an owl statue from thingiverse.com and showed you cost calculation example. You can see that all parameters are per hour based, so their proportions are permanent. Even the filament cost is basically per hour based, as longer prints consume more filament. The major influencer here is the printer speed setting and infill rate. Let's see what can be done about it.
Cutting cost. As you can see from my example, the printer and maintenance cost aside, the largest cost is filament itself. One of the things I have to state is to avoid cheap filaments, as they increase the rate of failed prints due to impurities and its variable diameter. This is a statement for me, as I have proven it throughout my work. You can also find it out on your own. Google search throws 6.7 million of links about it. When I started printing, the slicers were in its initial states. The results were long prints with lots of filament consumed. New versions use smarter algorithms which reduce print time and save filament. The first thing you can do is to lower your infill rate if hardness is not necessary. Simple upgrade of the software can lower your cost. New software can use new G-codes such as G02 and G03 for arcs, so upgrade your printer firmware too. There are even new dissolvable filaments which are meant just for supports. They are generally cheaper than mid-quality filaments. Electricity, not a major cost, can be lowered a bit by having a printer in its enclosure, if it's not already. It preserves heat dissipation. Mine is not. I have ruined many prints due to temperature drift while having a drought to get rid of ABS fumes. Personal cost, variable. Cost of supervision and maintenance time plus education/learning curve. Said it yourself. You ask, what is the cheapest and the fastest learning curve? I say, learn elsewhere on foreign costs and maybe even get paid for it. Joke or truth? Yeah, that's something. Thank you for watching this video. Don't forget to hit like, comment, share and subscribe. And see my other videos on YouTube.